Hello everyone, welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. In this session, we are going to discuss RC phase shift oscillator. As you know, all oscillator topics are very important for all competitive exams. And it is under Trickopedia. Let's trick it. Now, this is my introduction. I am having around 22 years of teaching experience. And these are my achievements. AIR 16 rank in ECE 2005. ECE means Engineering Services Exam conducted by UPSC. And AIR 21 in ECE 2008. And I have trained more than 1 lakh students for these exams. Now, RC phase shift oscillator. There are 3 types: by using op-amp, by using FET, and by using BJT. All are important for exam. Then first of all, what is the diagram by using op-amp? So we are having one inverting operational amplifier here, and that is what feedback network. First criteria, bar question criteria, total phase shift should be equal to what? 360 degree or multiple of 2 pi. That is what? 2n pi. Okay. So it will give 180 degree phase shift. It will give 180 degree phase shift. Total phase shift is what? 360 degree. Now, so that is the diagram, feedback network, basic amplifier. And this is RF, that is R1, and these are the RC. Then guys, what is the important formula? Frequency of oscillation 1 by 2 pi RC root 6, that is in hertz. And then condition for oscillation, mod of A beta should be equal to 1. That is the second condition, bar question criteria. From this, RF by R1 is equal to 29. RF is the feedback resistance, R1 is the coupling resistance of inverting op-amp. Then RF should be equal to 29 times of R1, but practical consideration, mod of A beta should be slightly greater than equal to 1. And that's why RF should be slightly greater than or equal to 29 times of R1. This is very important formula. Note this formula. Okay, then the next is RC phase shift oscillator by using FET. Here we are using the common source configuration, whether it is a JFET or MOSFET. It will give 180 degree phase shift. Remaining 180 degree will be given by RC phase shift. So total is what? 360. Again, first criteria satisfied. Then this is another way to represent the diagram. Remember, here we are sampling the voltage, we are mixing the voltage because it is a voltage control device. And that's why the feedback mechanism is voltage series feedback. It is a basic amplifier. We are sampling the voltage, we are mixing the voltage. Similarly, in case of operational amplifier, we are sampling the voltage, we are mixing the voltage. That's why the feedback mechanism is voltage series feedback. Now, important formula, 1 by 2 pi RC root 6, similar. And the condition, amplification factor mu should be equal to 29. Practically, it should be slightly greater than 29. So, these are the important formula. Now, next is BJT. By using BJT, BJT is a current control device. That's why we are sampling the voltage at this point and we are mixing the current here. But it is a common emitter configuration. It will give 180 degree phase shift. RC phase shift oscillator. This one, this portion will give remaining 180 degree phase shift. 180 plus 180, 360 degree phase shift. Bar question criteria satisfy. Sampling of the voltage, mixing of the current, and that's why the feedback mechanism is voltage shunt feedback. This is important point. Now that is another way to represent the diagram. Then guys, this is the frequency of oscillation 1 by 2 pi RC root over 4K plus 6, where K is RC by R. And this is in hertz. Then what is the condition for oscillation? The condition for oscillation is HFE, that is called beta, common emitter short circuit current gain for BJT, 4K plus 23 plus 29 by K, where K is RC by R. And what is the minimum value of HFE required? 44.54. Then that is the question, guys. For oscillator circuit shown in the figure, as an ideal inverting op-amp, its frequency of oscillation is 1 by 2 pi root 6 RC. So hope so you have enjoyed the session. For this type of session, stay tuned with us, subscribe our channel, like the session, and again, happy Independence Day, guys.